Now in this video I want to consider player movement specifically. You'll see we have our character in the scene here. Now there are several ways we could implement the movement for our character. In particular there are two main ways. One way is to create a completely free-form movement for the character, as we might find in many third-person 3D games. This movement allows our character to rotate around to practically any angle, like so, and to walk forwards in practically any direction. So let's just change this to a local axis, and we could move forwards this way, and then we could rotate a bit more and move forwards that way. And it's completely loose, and we can rotate and move in any direction at all. Now we could take that approach, but I'm not going to do it here, because here really we want to try and constrain player movement to a very rigid up and down, left and right grid, because otherwise that might damage the main game mechanics for a box pushing game. We don't want the player to start pushing boxes at an angle. The idea is that they can push boxes forwards, backwards, left and right in the four cardinal directions. These kind of incremental controls, these rigid grid fixed controls, are similar to games such as The Legend of Grimrock, where whenever the player turns and rotates, they rotate in a discrete increment. So he'll rotate 90 degrees this way, and if we choose left, he'll rotate 90 degrees that way, and if he moves forward, he'll move forward in a discrete increment and stop. So that's the kind of controls that we're going to be implementing in this, a kind of railroad control that constrains movement to particular axes. So what I'm going to do is I'm just going to return back to the main view here and jump over to MonoDevelop to take a look at our main movement code. So we're back to our code here, and I'm just going to scroll down here to the start function, and you can see that the first thing I do is I call a coroutine handle input, which is this coroutine beneath here, and this will be called on each and every frame. It's going to loop forever and be called on each frame to check player input. And effectively what I'm doing here on line 59 is I'm saying if the player is pressing the forwards key, then we want to set this state to player walk, and we're going to initiate another coroutine that will move the player forwards in the direction they're looking at by a specified increment, by the move distance. And if I scroll further up, you can see that by default the move distance is set to 2 world units, and it travels that over the case of move time. So for example, every second for move time, we're going to travel 2 units in the direction that we're looking. So what will happen is the handle input function here will initiate the move coroutine to move the player. And the move coroutine is specified here. It takes them from their current position and moves them forward over 1 second by 2 units. So once that's completed, it then checks to see is the player still pressing forwards, and if they are still pressing forwards, we'll move forward again another 2 units. And in that way the player will always move in specified increments in the direction they're looking. I just so happen to know, if I just minimize MonoDevelop, that the general width of one floor tile in the level is 2 units. So if the player is standing in the middle of, say, this floor tile here, and they walk forwards in this direction by 2 units, they will end up at the middle of this floor tile. And again, if they move forwards from this floor tile by 2 units, they'll move to the center of this one. Or if they rotate and face this direction and move forwards, they'll move forwards to the center of this floor tile by 2 units. So they're moving tile by tile, and that's what we want, because we want to constrain the movement of the boxes according to the general sort of grid arrangement that we have here. And if I go back to MonoDevelop, this is what this move function does. It allows the player to move forwards in the direction they're looking. You can see here we're using the forward vector of the object. So the forward vector is this blue arrow for the player here. Let me just switch over to the player character and take a look at them in the scene. You can see that the player is facing in the direction of the blue arrow, which refers to the z-axis that you can see here. That represents the forward vector of the player, the direction in which they are looking. So if the player was looking in this direction and I was to press the W key on the keyboard, they would move forwards in this direction. If I were to rotate by 90 degrees and press forwards, they would rotate in this direction. So that's the way the movement generally works. And if I press play on the toolbar, actually let's just maximize this, and I press forwards, the player is going to move forwards. Actually, I'm in the scene viewport. I need to switch to the game viewport. Let's just stop this, switch to the game viewport, press play, and now I'm going to press W on the keyboard, and the player moves forward and stops by 1 increment. So they've moved forward 2 world units. Let's just see this in action. And what I'm going to do temporarily is take this camera object, and I'm going to drag and drop it under the player character, so that now the camera will follow the player character because the transform will cascade downwards. So let's just maximize the game tab, press the play button on the toolbar. I'm going to hold down the W key to move the player forwards, and you can see them moving forwards. Again, we're continually moving forwards until I release, and then the player stops. So that's how that sort of generally works. Let's just take the camera out of that. And so right now what we can do with this code is move the player forwards in the direction that they're looking. And in fact, let's just go to the scene viewport, select the player character. Let's just rotate them 90 degrees, actually negative 90 degrees this way. Parent the camera to the game character, switch to the game tab and press play. And now have moved forwards. You can see the player character is walking nicely through the level. So there we have it. Right now we don't have rotation controls just yet. I'm going to be implementing all of the rotation and the collision detection mechanics in the next volume of this course. Right now I just want to show you how you can get some code in here to switch between the animation states and to move the game character. So that basically is how this code works.